So what is the data? So it's a collection of what facts we have it. It's a collection of like results, experiences, observation, and all these things. Okay. Now it can be numbers, it can be words, images, videos. Yeah. So because in YouTube you see a lot of data is YouTube videos. You have it, text, message, text, comments, okay, images, audios, videos. Okay. So these are missing over there. So you can add like videos and audios. It is also considered to be a data over there. Then we have the lowest level of abstractions. Means like abstraction means which you can think of. Means like you cannot go just like an atom. Okay, so atom is the most like lowest point of matter. Similarly, data is the lowest level of abstraction from which information and knowledge are derived over there. Okay, so now we see different types of data over there. You might be knowing this is what is the difference between numerical data and categorical data. Can anyone tell me what is a numerical data and what is a categorical data?
Numerical is like contains and provided numbers, but
Yeah.
the categorical it's all about letters and words.
Yeah, numerical is about numbers. Yeah, you are right. But categorical is about like alphabets. Okay, alphabetic data which has like A, B, C over there, while the numerical is like 1, 2, 3 over there. Right. But now inside the numerical there is further division. You see over here there are like two kinds of division. One is called interval data, another is called ratio data. Okay. Can anyone know what is the difference between these two kind of numerical data?
Maybe the interval, it's I can't count it. Same in the classroom, there is maybe 50 students, so I can't count them. Or the ratio.
You cannot count 50 students, so
No, I can't count it.
Okay, you can. Okay, right. Another one.
The ratio percentage, maybe.
Ratio is percentage.
Same the.
No, it's different. Percentage and ratio are different things. Mathematically, it's two quite different things. Ratio and percentage. Percentage is out of 100, and ratio is like nisba. You know what you call in Arabic? What do you call nisba, or what do you call it?
Yeah, nisba.
Nisba, yeah. So ratio is different thing. Like 1 ratio 3, like 1. That is different thing. Okay. So the results of the percentage and ratio is different. Okay, so just I give you one key point to remember in your whole life, that what is the difference between a ratio and the interval. Okay, in one of it the 0 is absolute, and in another thing the 0 is not absolute, it is a referential. In these two, in one 0 is absolute, 0 means 0. Okay, but another 0 doesn't mean 0. Okay, now if I tell you that for example, in space you have a 0 weight. Okay, right? So it means that, like for example, 0 means absolute 0 over there. Okay, if I say you got 0 marks, okay, so it means it's originally 0 over there. But if I say that there is 0 temperature over there, so if I say 0 temperature, so it means it means there is a temperature. It doesn't mean there is no temperature. So that is called interval. Okay, so when there is no absolute 0, we call as a intervals numbers over there. Like for example, I say 0 degrees centigrade. So it doesn't mean there is no temperature. There is a temperature, but we call it 0 means. So it can be like minus as well, -1, -2, -3. So you can go on the minus as well, right? But in the ratio number, you cannot go in the minus. So 0 means 0. Okay. So there is a difference between these two over there, right? So for example, say number of students. So you say there is 0 number of students. So it means there is no student in the class. Okay. You cannot say there is -2 students or -3 students. Okay. So you cannot say like this one, right? But you can say that today is -3 degrees centigrade. Yes, can you say? For example, like if you go to the Switzerland and you say, oh, there is -3 degrees centigrade, so it means it's valid. So you can say it, but you cannot say that today there was -3 students in a class. You cannot say. So the ratio is the ratio is the ratio is like when 0 is absolute, okay, that is called a ratio over there. But when 0 is not absolute, we call a interval. Can you tell me some more examples for these two? I gave you two concrete example of it. Let's give you some more example.
Interval may be like the IQ tests.
IQ test, yeah. So IQ test, yeah. So it's absolute or referential?
It's interval. There's the value of 0. It's
No.
absolute, I think.
So when there is a 0 is absolute, it's a ratio. It's not an interval. It's a ratio when So IQ, for example, IQ 0 means like, so it cannot be minus 2, minus 3. So absolute. That is absolute over there. Yeah. Interval. Now wait. What about the weight?
Weight.
Can you weight is absolute or interval?
Absolute.
Is an absolute, so it's
It's a ratio then. It's a ratio then. Okay, what about, okay, give me some more example about intervals. Okay, ratio is clear. Okay, what about the intervals? Give more example.
Temperature.
Okay, I give you very good example of the temperature over there. Okay, now find some relevant examples with the interval where you can go for minus as well.
Doctor, what about the age?
Age, yeah. So can one be, age is what? Can any person be minus 1 year or minus 2 years? If I say that Sarah is minus 2 years old, it's not possible over there. So it means 0 is an absolute over there. So it's a ratio over there. So age is a ratio, right? So now, okay, now tell me about interval where 0 is not absolute. 0 is a what do you call it? Like a, it's like a it indicator only. It's a reference point only.
The weather,
So 0 is, okay, absolute here. This is 0 is absolute over here. Here 0 is referential. So you can go for 0, minus 1, okay, and plus 1. Right? So this is interval where you can go for, so I need examples from you. Give me some more example of that one. Think about it, use your mind, okay. Make yourself more analytic, and because this is very important to know about the data. So if you cannot know about the data, it means like you don't understand the data. If you don't understand the data, it means you don't understand the data mining. SAT score, okay. SAT score, so SAT score is interval, interval or ratio, Sarah? It's interval, So can a person have minus negative score? Minus 3 score? If there is a negative marking, for example, if there is a negative marking in a test, okay, in a quiz, if I say, if there is like, for example, 5 questions and there is a negative marking and you made all questions wrong, so there can be negative marks, isn't it? Okay, so think about this one. Okay, we will please next time find some good example for me for both of that one. Okay, now come to the categorical data. So categorical means like A, B, C. Okay, right? Alphabetics. Okay, alphabetical. Numerical is done. Okay, 1, 2, 3, and minus 1 and minus 2. Okay, and in the middle 0. This is done. Okay. This is done, right? Now we go to the ABC. Actually, I'm thinking that I'm teaching you in KG1, KG2 class, but it is very data to understand the data. It's very important to know about this thing. Okay, so I'm giving you the example of this one is clear. All right. Now we are going to for the categorical data. So in the categorical data, we have two important terms over there. One is called ordinal data, and another is called nominal data. Okay. So now let's put this ABC into the ordinal data and the nominal data. Okay, what kind of data can be ordinal and what kind of data can be nominal over there? Let's suppose,
Ordinal is like it's like the country, the gender, the race, the hair color, anything. But the ordinal, we're talking about positioning, like first, second, third. Like when there's a race and the first winner, the second winner, you know, when there is ordering, which means we're using a ordinal data.
Yeah, very good, Batul. Yeah, you got the exact point over here. Yeah, so nominal is any kind of data where there is no order, where order is not necessary. For example, I can read green, blue, red, white. Okay, I can write like for example age. Okay, sorry, not the age is a number. Okay, and like for example any data. Okay, there's some example coming from the students. Yeah, a gender. Okay, yeah, okay, and right, so these are the different like for where there is no order is necessary over there. Okay, but there are hair color. Okay, right, red, green, blue, right. Okay, so all these are like nominal data where there is no order is necessary. You can write anything before that one. Okay, in case if you make it like alphabetic order. Okay, now the ordinal data. What can be the ordinal data? It is can be like for example first, second, third, fourth. So you need to write for example first, second, third order. Time of the data. Time of the data is if it is number, then you have to come into the numerical one. Okay. So time of the data. What do you mean by Sarah? Can you just elaborate what do you mean by the time of the data?
Time of day, doctor, not data.
Oh, sorry. Time of the day, like morning, evening.
Morning, yes.
Okay, right. So there is no any order in it.
It's in order, but in not number. So it's ordinal.
Yeah. Okay. So it's ordinal. Okay. Yeah. Very good. Yeah. So education level. Yeah. Very good. Yeah. So first you do Sanaviya, then Baccalaureate, then Magister, then Doctora, then Postdoctora. Okay. So this is kind of education level. Very good. Income level. Yeah. Low level, mid level, and higher level. Okay. Very good. Yeah. So like for the managerial level or like clerical level or the middle level. Grades. Yeah. Grades. A plus grade, B grade. So you cannot write B first and then A and then C. Okay, so you have there is an order in that one. Very good. Lulwa, you did a very good example, and Latifa, you too, and Sarah. So you are the winner of today class discussion. Okay, so I hope now you understand these examples over there. Okay. What does the DM do? How does it works over there? Okay. What does the DM do? How does it work? Okay. DM extract patterns from the data over there. Like what is a pattern? Okay. So what is the pattern? It can be a mathematical, numeric, or symbolic relationship among the data items. Okay. Sometimes you find an interesting relationship between the data items over there using some mathematical rules, some mathematical, numerical, or symbolic rules over there. So for applying this one, you can use the patterns in numerical, or you can use the symbolic one as well over there. Okay. So types of patterns. What are the different types of patterns we have it? We have like associations, we have predictions, we have clustering, we have sequential and relationship. These are different kinds of patterns which can be used by the data minings to find out the relationships over there. Okay. So we will see that how this can be used over there. A pattern is a certain model to follow. Very good. Yeah. So pattern is a certain model over there. Here is a very good example or taxonomy of data mining tasks. That what are the data mining tasks we have over here, and it is going to give us some more learning perspective over here. So here is the main two classification of the learning. Okay, even in like for example in AI or in data mining or in machine learning, you have these important things. So I broadly classify these into the two. Okay, one is called supervised learning, and another is called unsupervised learning over there. Okay, so and there is another kind of learning called enhanced learning, which is not included in your course, but just for your information, we call it as a enhanced learning, which is the mix of these two. Okay. Right. So now see over here, what are included in these two kind of learning models. So learning method is how much? Usually we have a 3 learning methods, but here is a more classification, two main classifications, supervised and unsupervised over there. Okay. So in supervised we have like prediction, classification, and regression. So these are the important things. And what are algorithms we have? We have like classifications, we have regression trees, we have SVM, we have a decision trees over here, we have we have like a artificial neural network, we have MLP, we have a support vector machine, we have a ref sets, genetic algorithms, linear, non-linear regressions, SVM. So these are the popular algorithms. You don't need to remember, but just you need to know that what these algorithms can do for you. Okay, so being a data mining expert, you must know that if I am doing supervised learning, which algorithms I need to choose for my data so that it can give me the best result for me. Now see over here, so for predictions, so if you want to do predictions in your data, if you want to know the future trends in your data, so go for the supervised learning, and you can use any of it. You can use classification, you can use regression trees, and genetic algorithms. If you need classification or regression, you can use all these methods over there. But the most important thing is that when should I use the supervised learning? This is important thing. Okay, the question is that when should I use the supervised learning? Okay. You can use supervised learning when your output is fixed, like for example the tree structure. See, the tree structure, you have a fixed shapes, like for example you have like you know that how many inputs I have it and how many outputs I have it. Okay, so it is for example your tree structure, so you know that my outputs are for example 4 outputs here. See, so when the outputs are fixed, okay, when inputs and outputs, you know that what is my input and how many outputs I will get it. So when your outputs are fixed, then you go for the supervised learning. So classification, the classification tree is one of the most important example for that. Tree helps you, tree structure helps you to give you outputs for your learning over there. Now we come to the unsupervised learning. Okay, so if you learn this thing, so the rest will be unsupervised. See, so it's very easy. You just need to remember that in supervised we have a prediction, classification, and regression. Okay, and these are the algorithms over there. That's it. The rest are unsupervised. So this is one of the key points for you to learn these things. Now we come to this one. Okay, this set. Here the output is not known, means like for example sometimes you will get 2 outputs, sometimes 3 outputs, sometimes 4 outputs. Why? Because it is unsupervised. Okay, means the output will be under the control of the algorithm. Okay, you will not be knowing that how many kind of output you will be having. Sometimes we have it, for example this is your, let's suppose this is your data, let's suppose this is the data of the mom, let's suppose. Okay, for example this is the data of the mom. Okay, population. Okay, so some of my customer, okay, are here. Okay, some of my customers are here, some of my customers are here. For example I am like locating McDonald's is locating its customer. Okay, some of our customers are there. Okay, so 2 customers are here in Khubar, 2 for example like 2 in Raqqa, 2 in Dammam. Okay, and 2 in what to call it, like a for example in Dahran. Okay, so see, so how many cluster I have it. See, so I have, this is my first cluster, this is my second cluster, this is my third cluster, and this is my 4th cluster. So I have how many? 4 cluster. If one customer move from here to here, let's suppose, okay, so there will be only one. So with the one I cannot make a cluster, so I will combine these 2. Okay, so it means that how many cluster I have now? 1, 2, and 3, right? So sometimes the output is not known. Why? Because your customers are moving, your points are moving. The points are very important things over here. Okay, so this is called clustering. Okay, so clustering means like k-mean. So k-mean is, this is the graph I made, it is by k-mean over there. Okay, so they see that the distances. So here the distance is more. See, from this point to this point the distance is more, so it cannot be clustered. But from here to here the distance is less, so I made a 1 cluster over there. So you can use the like a Manhattan distance, or you can there are two kind of distances. Do you remember? One is Manhattan, another is one Euclidean distance. You know Euclidean distances? Do you know about it? In Sanaviya, you read about it. Euclidean distance. There is a formula as well. X, y minus y, y2, x minus x2, and with the square and with the root. Okay, there is a distance. So with the 2 points, how can mathematically or programmatically I can know about the distances? It is about the Euclidean distance, or you can the Manhattan distance. The difference between the Euclidean and Manhattan is that the Euclidean, they have a plus sign in the middle, and the Euclidean, they have a negative sign in the middle, in the both sides. Okay. So this is the difference between the Euclidean and Manhattan distance over there. So now I was telling you the main difference between this one. So we have association. In the association, what we can do it. The most important thing is that you associate things. Like for example, if you go to the hyper mall, okay. So usually when you want to buy a tea, there will be a milk nearby with it. If you want to buy a tea, there will be sugar along with it, pudding, so that you buy similar things together over there, right? So usually what they do it, they keep things near to each other. So this called there's algorithm is called a priori algorithm is used over there. So you can see over here a priori algorithm is used over that one. Like for example, if you want to buy a laptop, so they will keep an antivirus CD with that. If you buy, there is a discount for it. See, this is one of the techniques that how you can increase your future sale for that one. This is called association mining. Inside the association, there is a link analysis and sequence analysis, and this is a list of algorithms you can use it. Clustering, I told you what is a clustering. To make like k-mean is one of the algorithm for clustering, and all are, this is unsupervised over there. And there is another one is called outlier analysis. What is an outlier analysis? In the outlier analysis, what you do, you find the points which are like away from the normal. Like for example, these are your points. Okay. For example, these are your points. I draw just like a dummy points. Okay. And there's a 1 point line here. Okay. So this point is an outlier. Okay. This is a cluster. Okay. This is a cluster for you. Okay. These 5 points are okay, right? This is an outlier. So what is this for, and why I am interested in this point? Okay. Because the outlier, usually in the outlier, I can find some cases of fraudulence, you know, in the banks. In the banks, for example, this 5 customer, they pay regular. My, like for example, my loans, things, or like for example, credit card payment, they do in a regular way. This one is not doing it, so this is an outlier for me. Okay. Or in like for example, in a company like an automobile company, these, for example, for these companies, these 5 cars, their parts are working well, but there is a one company, these parts are not working well. Okay, so this is an outlier for it. Okay, so you can group different things and you can see where is the outlier over there. There is one case, for example, Enron. You might have heard about that one. Maybe in business ethics, you had this case study over there. Enron was a company in US, and they had like a they were like a what do you call it? Fraudulent cases over there. People like there was embezzlement of the money in the Enron case over there. Okay, and they were then sued for that one. Okay, so we also worked on that. We took that data set and we saw the interaction of the emails over there, and we find that one. What are the outliers over there? And we use the k-means over there. So k-mean we used over that one, and that paper is published online. If you want to check that one, you can find it that the dissimilarity of the Enron data sets over there. I will just share that database with my paper with you for your extra reading over there. So this this data mining task is just to make you a clue that what algorithm is to use and what algorithm is not to use. Your duty is not to create this algorithm. This algorithm has already been created. Your wise decision will be which one is the best for my data. This is your task. This will be your, like, you know, duty over there when you become a data miner in any company. So data mining task means like sometimes some of the data may be time series, like Tadawul. In Tadawul, you have a like time series data, and there is transaction with respect to the time. The banking, they have a time series data over there. The weather forecasting, they have a time series data for 10 years, 20 years, and even more than 50 years as well. and it's a part of sequence, and so you can use the link analysis for it. So other like k-mean will not be a perfect choice for it. For that, link analysis will be perfect choice for it. Visualization, you can do it like data mining tasks with the Tableau, you can do it. Types of data mining, you have it like hypothesis driven data mining, discovery data mining, etc. You have it. And then we have like data mining applications, we have it like customer relationship management, we have it where we can use in the customer relationship management. Usually customer is a money for the company, how to retain the customer, okay, and like how to improve the customer and how to retain the, that's called, when you want to retain your customer, this is called churn analysis. This is very important terminology. It's called how to improve the customer retention. Sometime when you want to like switch from like one network to the another network, like Mobile to the Zen, so they usually call you, they want to like persuade you, please don't go, okay, we will give you some extra bonus, don't go, okay. Similarly, if you want to change from KFC to the McDonald's, they will also like give you some offers, more offers. The one of the thing is of the offer is that to retain the customer, yeah, and maximize the return of the marketing campaigns over there, maximize the customer values, okay, how to you can maximize the customer value. It's called cross-selling and upselling over there. And identifying and treat most valued customer. Some customer are very valued, they give you a lot of like revenue over there, so you have to identify and also treat them well and give some more respect and bonus to them. In banking sector, yes, automate the loan process, detecting the fraudulent transaction, maximize the customer value, cross and upselling, optimizing cash reserves in the forecasting, and all these things. So it can be used over there in the banking as well as in the customer. Now retailing, in the retailing it can be used logistics, like optimize inventory levels over there, improve the store, optimize logistic, and minimize the losses due to the limited shelf time. For example, some of the items are like, you know, expiry dates are there, like for example food items, especially like for the milk item, they have like very short like lifetime over there, or meat items. So minimize the loss of due to the limited shelf life over there. Manufacturing industry, they can use the data mining, predict machinery failures, when my machine is going to fail, when, for example, like expected time of the failures according to the different factors, anomalies in production system to optimize the use of manufacturing capacity in different firms over there, and novel patterns to improve the product quality over there. Brokerages, do you know about the brokerages and security trading? What do you mean by brokerage? And what do you call in Arabic? Yes, brokerage. Have you bought some shares, market shares in Tadawul or somewhere?
It is the third party or the third person.
Exactly. Yeah. Exactly. Yes, you're right. Yeah.
The seller.
Yeah. So if you want to sell your some shares, so there are third parties involved over there. If you want to like, so brokerages are there. Okay. And there are security tradings over there. So it can also be used over there. So the data mining can predict changes on certain bond prices, forecast the direction of stock fluctuation. How is my stock going on? What is the stock position of the Aramco? What is the stock position of the other things over there? Okay, and assess the effects of events or market movements over there, and identify and prevent the fraudulent activities in the trading over there. And then we have like it can be insurance, especially you have Taunia, you have Wafa, you have other Kambupa. So insurance companies, these can be also used. Why? You need to forecast the claims cost for better business planning over there, because the insurance company, they also want to earn money. So they forecast according to for example, if there is more accidents in a city, so the insurance will be high. If there is less accidents, like for example in villages there is low traffic, so the insurance will be lower over there. In Riyadh there is very like for example a lot of hustle and bustle, and there is like a lot of accidents on daily basis. So, and especially on like Jubail highway, there is a lot of accidents over there. So maybe the insurance for different places are different according to that one. Determine the optimal rate plans over there. So rate plans, this is important thing. Optimize marketing to specific customer, how to marketize your thing according to that. So data mining will tell you where to market more, because if your customer are less in Jubail, so you have to do more marketing in Jubail rather than in the map over there. Identify and prevent fraudulent claims activities. Okay, sometimes some of the claims are fraudulent. For example, the car is not hit in accident, it was just like hit by a wall or something, and they claim for that one. So how you can find out the fraudulent cases over there? So data mining applications are everywhere in computer hardware and software, in science and engineering, government and defense over there, homeland security and law enforcement, travel industry, healthcare, medicine, and entertainment industries over there. So everywhere is data mining process over there. So what is the data mining process? There are three most important models over there. One is called CRISP model, which is called CRISP stand for Cross Industry Standard Process of Data Mining. Second is called SEMA model. SEMA means sample, explore, modify, model, and assess over there. And the third model is the knowledge discovery in the database over there. Okay? So a manifestation of the best practices, we have it a systematic way to conduct data mining projects, and different groups has a different version for that one. Okay, so we have a three most common important data mining processes. We have it, and you can see that in the data mining process who uses what. Okay, so see, CRISP DM is like widely used. Okay, this is my own means, like the person who has done this research on kdnuggets.com. So they have like their own process. SEMA is used little bit less. KDDM is less. Okay, MyVersion less, none. Okay, and domain specific. This is one of the case study results. Now we will study these three models. After the break, we will have like a 20 minutes break. Okay, after 20 minutes, we will be studying this CRISP model. Meanwhile, you can look at this diagram and see what are the different processes, and we will discuss the process one by one, that how these models can be done over there. So we will have this CRISP model, then SEMA model, and then we have a, for example, KDD models over there. Okay, right, and then we have a clustering. Okay, so this chapter is a little bit bigger, so we will try to cover as much as we can. Okay, so after the break, we will try to cover rest of the chapter. Okay, so for time being, you can focus on this thing. Okay, this CRISP model. Okay, this model. Okay, so maybe maybe because of the problem in the zone, it will like shut down. Okay, and then we will log in again. Okay, right? So in case if it is shut down, please you just like log in again, no problem, right? So take your break. Okay, enjoy the tea, and then you can we will come back after 20 minutes. So see you after 20 minutes.